So we heard a wonderful talk from Jeff in terms of self-awareness and in terms of potential applications in robotics. What I would like to do is to take one step back and I try to understand what self-awareness means, because self-aware computing or self-aware networks has been terms which have been used for decades, at least a couple of decades. To do that, as a computer scientist, I thought maybe I can take a big step backwards. It's really to look at what might be the major challenges in developing new computing systems. So if we think of computer systems, and then we kind of connect them with a few words, like they are large, there will be heterogeneous, there will be uncertainties in the systems, they are often operating in a dynamic environment, and many such computing systems are fully decentralized. And then if we look at what kind of requirements we might attach to these new computing systems, normally we'll specify them as goals. For example, if we develop a system, we set we want full flexibility. And then, of course, we want a system to have high performance. And then I want to have a minimum resource usage. I have requirements in terms of very high security, in terms of very high reliability. All those are very nice properties we demand from a computing system. Unfortunately, a lot of them are actually conflicting goals. If you want a high performance, sometimes the resource usage might be high. If you want a minimum resource usage, maybe we will compromise the security or reliability. When we try to measure the behavior of the system, normally they are measured over multiple attributes. So the key challenge in designing new computing system does not appear to be, let's design a wonderful system which can optimize certain criteria. Instead, which seems to be how to dynamically manage such changing goals at the runtime. How do we get this trade-off? We want high performance from system, but I want to pay very little price. I want to use a very minimum usage. So that's kind of a context. I'm going to introduce kind of a vague idea. So in the future, when we develop a system, I would like to develop a system as a collection of self-aware and self-expressive nodes. What do they do? Well, I hope they will learn, they can interact in order to self-adapt to a dynamic environment. They can self-organize in terms of dealing with uncertainties. So that's kind of idea and the direction I'm moving towards. Now that I use the word of self-aware and self-expressive nodes, what do they mean? There are many meanings of self-aware computing or self-aware nodes, and people can find it in the literature. I won't go through all those literatures one by one, but let me just show you the version which I like very much. So here's one working definition of a self-aware node in my context. Okay. So for a compute node to be self-aware, it must possess knowledge about its internal state. So this is kind of, from a psychological point of view, is called the private self-awareness. And then to be self-aware, a compute node must possess knowledge about its environment. So this self-aware, it really means the knowledge about the self and knowledge is about the environment. Okay. So conceptually, we can try to condense all this into a graphical form. It's like this. Okay. So in terms of self-aware node, so you have this private self-awareness is really about knowledge about the internal state of the compute node. By the way, compute node can be a piece of hardware, can be a piece of software, or can be a combination of both. And then a public self-awareness is really about the knowledge about the environment. The environment consists of the physical environment and other nodes. And then a very important component is this learned model. So for compute node to be self-aware, it must be capable of building an internal model of itself and its environment. Now, what does it mean to be self-aware? What do you mean knowledge about itself and the knowledge about the environment? Can we say a little bit about the knowledge? So here are levels of self-awareness according to two very well-known psychologists or cognitive scientists in the 90s. They classify this self-awareness into different levels, which are very, very interesting. We can actually map into computer science domain. So
We are having some technical difficulties.
taking too much time?
Perfect. No, you're back on. Perfect.
Okay. So this private self really describe goal awareness. And that's something very interesting. So if we're looking at a self-aware node, a compute node, is aware of in terms of spatial relationship, in terms of a temporal relationship, as well as the capability of managing goals. And then we have this self-concept in terms of capability of abstraction. Being self-aware is not a final aim. And then changing the world is one of the final aims. So self-expression really describes the process of determining the resulting actions. So based on this knowledge of itself and the environment, we can express ourselves and then taking actions. And then the actions really can be acting towards external ones as well as internal ones. So this kind of graphical abbreviation of a concept of self-expressive node. So when I mention designing a collection of self-aware and self-expressive nodes, so this is kind of a conceptual model, if I may, where the upper part represents the self-awareness. Based on this self-awareness, and then we can have a self-express engine. So we have quite a learned model here. We have quite a lot of learned model here. Okay. So this sounds very abstract. So I can show you just one example how we can potentially transform these conceptual ideas into engineering systems. Okay. And then to do this in terms of software, we can actually come up with software design patterns based on self-aware and self-expressed concept. Basically, if we design a system, if we want a system to have, let's say, spatial self-awareness or time self-awareness or goal self-awareness, how do we do it? So there are actually guidelines enable us to do that. If we really want to find out more in terms of how to go from the conceptual ideas to some design architectures, to design patterns, and some examples of engineered systems, I suggest you to read the special issues. Thank you very much. That will be my short introduction and then short presentation.